So this is our GUI, and we have divided it into three main parts. First one is the data tab, second is the networks, third is the result. Let's move on sequentially and go through to the data tab first. Here the user can upload images, select the label and upload them. The user can also select images and add his custom label and add a class. So after refresh, you see our uploaded image. Now the user can crop the image he just uploaded. Let's just save this as duplicate. You can select and delete them, select them all, or edit them from here itself. We also have some powerful filters like transformed only, which shows the images transformed by the user. We have date filter, and we also have search bar to search class wise for all the images uploaded. Now moving on to the edit and transform tab. Here let's say we select images and edit them. We have array of transforms to apply to this image. Let's apply a few. And save this image. Let's save this as duplicate. So this filter was applied to all the images which we selected. Let's move on to the visualize tab, where we can see all the images of the data set and the ones which user added. So here for example we can see the 10 sampled random images from this data class. Now moving on to the networks aspect. Here we can choose one of the 4 networks which we have provided. We can easily extend that. User can choose either of these 4. So this is a custom network built by us for GTSRB. This has been trained on these hyperparameters, and we can see the gradients while training these images. So user can see the layer wise contribution, the kernel wise contribution of each layer. So you can see the type of layer, which is layer 2, and its dimensions. So if the user has to train this network on his data, he has to modify these hyperparameters if he wishes to change them. Let's change a few, save them. And move on to the training tab. So here the user can select his train test split. Let's save it as 15. To balance the classes, we have used SMOT, where the user can provide the factor for each. Class, or just use auto generate to generate SMOT factors for all classes. Here we have also provided an information tab as to what SMOT is. Now the user can start his training. As this ETA has now top 0, we understand the model has stopped training and has gone into the evaluation phase. Now as the pop-up suggests, the training has completed, and we can move on to the results tab to see the results of this training. Here we can choose the model of which we want to see the results. So we trained on baseline, so let's choose baseline. So these are all the results we have on baseline. Let's choose the latest one. You can see the embeddings of images throughout the layers. You can see the model has performed good on this data. Here we can see the top 5 best and top 5 worst classes in the data set. Now moving on to wrong results tab, you can see the confusion matrix of result 30 of baseline model. So here choosing any of the class, we can see this as misclassified. It has true class top, but its predicted class has no vehicles. So now selecting this image, we can go to suggestions tab to know what went wrong. Here we can see the images given by GradCam and Lime. So as we can see, the model is not taking the proper sign, and GradCam has no heat map points near the sign. So these are some of the suggestive measures which can be implemented to get better results, and these are the explanations of training and these results. We also see the precision, recall, accuracy and F1 for all the classes which we obtained during the evaluation.